Have you ever gazed up at the night sky and wondered about all the stuff floating out there besides the planets and stars? Our solar system is a busy place, filled with countless smaller objects. Two of the most famous neighborhoods for these objects are the asteroid belt and the Kuiper belt. At a glance, they might seem similar. Both are vast regions of space filled with rocky and icy bodies. But their locations are the key to understanding their dramatic differences. The asteroid belt is our relatively close neighbor. It's a donut-shaped region located between the orbits of Mars and Jupiter. Think of it as the main dividing line between the inner, rocky planets like Earth and the outer, gas giants like Jupiter. This proximity to the Sun plays a huge role in what the asteroids are made of. The objects here are primarily composed of rock and metal. They are ancient remnants from the early solar system, over 4.6 billion years ago, that never quite managed to form a planet. Why didn't they? The immense gravitational pull of Jupiter is the main reason. Its powerful influence stirred up the material, preventing it from clumping together to form a large planetary body. So instead of a fifth rocky planet, we have a belt of countless asteroids. The number of asteroids larger than 1 kilometer in diameter is estimated to be over 1 million, with millions more smaller ones. But don't let the movies fool you. The asteroid belt is mostly empty space. If you were to fly a spacecraft through it, your chances of hitting an asteroid without careful aiming would be incredibly low. The total mass of all the asteroids combined is less than that of Earth's moon. The largest object in the belt, Ceres, is so big that it's classified as a dwarf planet. Now, let's journey much, much farther out to the Kuiper belt. This is a far more distant and mysterious region. It lies beyond the orbit of Neptune, starting at about 30 astronomical units from the Sun and extending out to about 50 astronomical units. An astronomical unit, or O, is the distance from the Earth to the Sun. Because it's so far from the Sun's warmth, the objects in the Kuiper belt are very different. They are composed of volatiles, which are frozen substances like water, methane, and ammonia. These are essentially giant, icy snowballs, preserved in the deep freeze of the outer solar system. The Kuiper belt is a relic of the solar system's formation, a vast repository of primordial material. This region is also much larger and more massive than the asteroid belt. It's about 20 times as wide and estimated to be 20 to 200 times more massive. It's home to some of the most well-known dwarf planets, including Pluto. For a long time, Pluto was considered the 9th planet, but the discovery of other similar-sized objects in the Kuiper belt led to its reclassification. Scientific research from missions like NASA's New Horizons, which flew past Pluto, and another Kuiper belt object named Arrokoth, has given us incredible insights. These missions confirmed the icy composition and ancient nature of these distant worlds. The Kuiper belt is also the source of many short-period comets. These are comets that take less than 200 years to orbit the Sun. Occasionally, a gravitational nudge from Neptune or another large body can send one of these icy objects hurtling toward the inner solar system. As it gets closer to the Sun, the ice begins to vaporize, creating the beautiful tail we see. So in essence, location is everything. The asteroid belt, situated in the warmer inner solar system, is a realm of rock and metal, remnants that Jupiter prevented from forming a planet. The Kuiper belt in the frigid outer reaches is a vast, icy frontier, a time capsule from the birth of our solar system and the home of dwarf planets and comets. Both belts are crucial for understanding how our solar system formed and evolved. They are not just empty space, but dynamic and fascinating regions of our cosmic history. Studying them helps scientists piece together the puzzle of planetary formation and the distribution of materials across our solar system. Thanks for watching. We hope you enjoyed this journey to the far reaches of our solar system. For more amazing space content, be sure to subscribe to Space Repo.